Let's get started with Geoffroy Bali from NVIDIA. He's going to be talking about the high performance compute availability HPCA benchmark project for smart networks. And he Geoffroy is a colleague of mine, and we're looking forward to learn a lot about his benchmark effort. Geoffroy, please. Yes, we can hear you, Geoffroy, and feel free to introduce yourself.
Okay, and I may not need the entire 30 minutes, so even if people come up with questions about UCC at the end, we should have a little time. So yes, today I will talk about HPCA. So this is a group that I'm co-sharing with Steve Poole, and I will give the details in a moment. Why is it not moving? Here we go. So the mission statement. So the idea is really to provide a comprehensive set of benchmarks to evaluate the overall compute resource performance in the presence of in-network computing technologies. So this is exactly what is on the slide. I just read it out loud, but that's a very important part to remember, and I will explain in a moment why. So basically, we want to do that because our ultimate goal is to promote in-network computing in the context of HPC. So in other words, the idea is to show how much the new hardware, the new technology where we can offload computation or whatever to the network, how beneficial it could be to HPC applications, simulations or whatever, and give very specific metrics to the scientists, to the developers about why they should use that technology and how it could help them and how much it could help them. So for that, we want to provide a benchmark suite that captures its benefits. And again, this is really targeting smart networks. And right now, especially in my context personally, but it's true for everybody as far as I know, offloading is one of the big aspects of it. So how much of the computation can you offload to the network? And that includes if you have smart NICs, but also capabilities at the switch level. So the group is composed of vendors, national labs, and a few universities. It's not only the US, we have people from all over the world. It is, even if it's a lot of different institutions, it's still a small group, which means we can still discuss about the technical aspects, which I find very nice personally. And the idea is really to design and implement this benchmark suite I've been talking about, but not necessarily replace what is existing. The idea is really to leverage what is already there and identify gaps potentially in develop new benchmarks. And I will explain at the end, or toward the end of the presentation, one of the new benchmarks we have and why we ended up developing that benchmark. So that gives really an overview of the effort. It's a lot of discussion and some code at the moment. I will really encourage like every group that presented during these 3 days. If you are interested, please join the group and give your feedback, give your ideas. I will present the next slide, the use cases, and you will see we have quite a very open goal. But the first thing I would like to do is clarify the relationship with OpenSnappy, because this is a question I have quite periodically. There is no competition with OpenSnappy, and for a very specific reason. So first of all, just as a reminder, OpenSnappy is the working group within UCF that is focusing on developing new APIs for the smart networks. So for our group, we really focus on the benchmarking. We are not there to define new APIs. However, there is by design a synergy between the two projects, meaning that if OpenSnappy is developing new APIs, we will try to provide the benchmarks to give metrics to show how beneficial these APIs are. And on the other hand, if we find issues with the APIs from a performance point of view, we will feed it back to the OpenSnappy group. So it's really no competition, it's really a synergy, it's really to help each other. And now that it's clarified, I go back to my use cases. So those are the use cases we identified early on. And as you can see, it's quite extensive. This is why I was saying earlier that it's really, if you have any ideas, any suggestions, please join the group, it's open. And we are at this point still looking for information and feedback, basically. So the first one is parallel computing, and I will go through them very quickly. I will come back after I go through the list to specify a few points. But so the first use case is parallel computing. The other one, the second one is bring math closer to the network. Then we have basically the memory subsystem. So what is impact of in-network computing from a memory subsystem point of view? I/O and system noise. In my mind here, it's more in the context of file system and storage, improve locality, machine learning, security, and virtualization. And again, here, the goal is not to define new solutions, right? It's really to see what metrics we could provide and what benchmark we could develop or put together so that we can give a comprehensive view of the benefit of these new network technologies for all these use cases. So right now, the current prototype, it's targeting parallel computing because it's what we know very well, and I will talk about it in a moment, so I will give more details. We start to discuss about some of the other aspects, especially multi-threading. Sandy had a lot of interesting ideas there. Machine learning, there is also some of the members working on that, but it's not yet part of the benchmark suite, and we don't know when it will be brought over. But just to say that all these pieces are moving along, it's really based on everyone's interest. If you join the group, you don't have to be interested in all these use cases. You can contribute to only one or a few of them, and we will try to accommodate everything and everyone. So the software, as I said, right now we are focusing mainly on parallel computing, the traditional HPC, I would say. And the idea is to provide a set of metrics that capture these in-network computing benefits, features, how it can help programmers to accelerate their applications and simulations without modifying their application. That's the current goal now. I'm not saying that it's set in stone, that we will not extend that later on and investigate how or provide metrics that shows the benefit if you want to change your application. But right now it's really using NPI, so no modification of the application. The current implementation is based on 3 different metrics: latency, bandwidth, nothing new there. And I will explain how we do that in a moment. And we have also overlap. Overlap is not a new concept either. It's been provided as a metric by quite a few benchmarks. Will it be OSU for the non-blocking collective, or SMB for the point-to-point collective with the MPI overhead, which is a way to calculate overlap. So the idea here is really leverage what we already have for collective operations, point-to-point communications, contiguous and non-contiguous memory. Non-contiguous memory is especially interesting to us at NVIDIA for all the reasons, because we have hardware features like UMO that could be quite interesting in that context, and overlap. And I would give more examples here. And to get these metrics, we currently integrate OSU, SMB. Young Kim, one of my colleagues, extended OSU for non-contiguous memory. So we have that extension in the benchmark suite, and we have a new overlap benchmark. So that new overlap benchmark is really not designed to replace anything, it's just a different approach. And you will see in a moment, it's actually a combination of different ideas from SMB and OSU. So I want to make it clear, it's not to say that the existing benchmarks are limited or do something wrong. It's really to capture something in addition of what they do. So the new overlap benchmark, and that's the first time I present those details in public. So again, if you have feedback, speak up at the end. I would be interested to get as much feedback as possible. So as I said just a minute ago, it's really designed to complement OSU. So OSU, the way they calculate the overlap is for non-blocking collectives, they calculate the time it takes for a specific data size. And then they try to inject work, they calculate the time, and they do the ratio between the two. And that's fine. Now, again, there is no problem with that. By experience, I know that from a user point of view, it's quite limiting because it does not give people a way to understand how much work they can actually inject and still have good overlap. So the idea is how much work, the question would be, how much work can you inject between the time you post your collective operation and the time it completes, and still make sure that it does not delay everything, that you have good overlap. So what we did there is we kind of combined the idea of SMB with the approach of OSU. So in SMB, when for the point-to-point communications, what is done is that they basically calculate how much time a send receive for a specific size takes, and then they try to push to inject work as much as they can to see if you can have overlap, if the overhead, what they call the MPI overhead, is acceptable or not. So here we kind of do the same thing with non-blocking collectives. It's to have an estimate of how much time it would take to complete the operation without any injected work, and then try to inject as much work with good overlap, and then calculate the ratio. So it's really different, but it gives more details to the user, to the developers about that amount of work that can be injected, what is possible to do with the hardware. And as you can imagine, since we have smart networks where you can have some of these operations offloaded to the network, potentially it means that the overlap can increase. And I will show you, if I have time at the end, some of the results without any offloading. And you will see that the overlap right now is not that great, and there is really space for improvement when you use a smart network. So yes, so a few more points that I want to highlight here. One of the problems we have with overlap, and that is not specific to the new benchmark, is that when you run your test, you receive variability between the runs, and that's just the way it is. Just because historically, the libraries, MPI, and everything else was not really designed to have offloading or anything like that. And as a result, we ended up with quite a bit of variability between runs. This is something we have to keep in mind. This is something we have to deal with. But I mentioned this because one of the initial motivation for the new overlap benchmark was to take into account that variability. So make sure that when we provide the end result, this is from a statistical point of view, the best we can do in the context. This is also one of the other results is to have a statistically relevant result, it may take a long time to run. We may have to run many iterations. And with the first implementation we had for one specific non-blocking collective, we actually ended up having the test running 1.5 hours on some of the platforms we have. So one of the points we try to do, one of the goals we have with the new benchmark is to try to find a way to make sure that this test would be interesting, relevant, but also will not run forever. Will not run for hours at time, so that we can have an idea of what the metrics are in a decent amount of time. So we gather actually in the new benchmark quite a bit of details, but we also try to have a unique metric at the end, so that if we get one metric for non-blocking R2R, another one for R2RV, we can actually compose and combine these metrics together to give a final result to the user. And I will give an example at the end of that. So the implementation, so we have a two-phase algorithm. The first phase is really to try to find the configuration. So what do I mean by configuration? So for most of the collective, it's really about how much data you need to exchange at the scale where you are to make sure that it runs long enough to have a statistically relevant result at the end when you inject work. So as a data size in the context of API, it means it might be a different set of parameters. For example, for auth4v, to be a different count and a different type. But once we have that configuration, the next step for that phase is to calculate the average execution time and the standard deviation for that configuration. So nothing fancy here, just we make sure that we execute the configuration over a few iterations, and we get these two data. From there, once we have the execution time, the reference execution time, and the standard deviation, assuming we want to have a 90% confidence interval, and I choose 90% just because from a statistical point of view, it's what most people do. But once you have these two parameters, meaning standard deviation and the confidence interval, you can calculate how many iterations you need to have a good result. Again, since we don't want to have the benchmark run forever, we have the possibility to set a maximum number of iterations. So if the number of iterations that is calculated here is above that maximum, we just decrease the number of iterations. So it really decreases the accuracy of the result. But again, this is a way to have a default configuration where it will not run for a long time, and we can get some results in a predictable amount of time. Once we have that number of iterations, the reference time and the standard deviation, it's very easy to calculate the work equivalent. So it's how much work in theory you can inject to have that execution time during, that is basically the time between the post of the operation and the completion. And then we can move to the phase 2, which is a benchmark loop. So we have all this information, the reference time, the work equivalent, and the standard deviation. And from there, we can have a loop where we try to inject that time, that work. If we discover that the overlap is not good, that it takes longer than the reference time, we just decrease that time, we try again. And as we execute the loop, we find the upper bound and the lower bound slowly, but for sure. The upper bound would be when we know for sure that the overlap is not good. The lower bound is when we know that the overlap is good, and we slowly close the gap between these two, and when the gap is small enough, we stop. That's basically the idea. And that approach, based on all the testing I did on all the platforms I have access to, is actually really reliable, meaning that when the results between different scales and different runs is very stable. So that was one of the initial goals. That's the good news. And it gives us the metrics we are looking for. So now about the software itself. So we are preparing the first release. So we have a release candidate out there. And what is inside is a complete infrastructure to make it easier to install everything and to run everything, and ultimately at the end, analyze and visualize. You can still run everything by hand if you choose to. It's just not designed to be that mode by default, and really to let the system configure everything correctly, so we have some kind of confidence in the end result. And this is supporting the benchmarks I described before. This is supporting Slum. We make sure that everything is submitted correctly. If there is a failure for whatever reason, you can start back from where it stopped. We have all this type of little useful features in there. That's why there is, I spent quite a bit of time to integrate everything together. It's really to make it easier to just run and gather all the data together. And at the end, we get this final, these 3 metrics: latency, bandwidth, and overlap. We have a web UI to make it easier to analyze and visualize the data. So of course, as I said, you have these 3 metrics, but it also plots some of the results, especially for SU. And we can also compare side by side some of the results. And if you have time, I will actually show you very quickly what it looks like. So here on the right-hand side, you have a screenshot, but again, this is a very basic stuff. I will show you more details in a moment if we have time. There is a URL for the project on GitHub. Some of the future work is, so as I said, and I think it was clear right now, it's only based on MPI, which has its limitations, right? We are far away from the hardware. The benefit is it's totally agnostic from the hardware. So it will run on the NVIDIA hardware, it will run on other hardware. By the time you can run an MPI application on the hardware, it should be fine. But that really abstract, it does not capture some of the low level capabilities that would be interesting to understand better. So our next focus would be really, at least from my point of view, to try to get closer to the hardware. And that involve, as I mentioned earlier at the very beginning of the presentation, maybe to try to see if we can have benchmark on top of OpenSnappy. And so far, we did not really include that in the benchmark suite because OpenSnappy is still work in progress. They have some very good stuff in there, but there is still some point that need to be clarified. So that's why it's not in the first release, but we really plan to include that later on. And then I had, we could potentially include some new benchmarks also for OpenSHMEM. I am not an OpenSHMEM expert, so that's not something I can really comment on, but that was something that was expressed in the past. People express interest in having these benchmarks on this side by side with MPI, and I hope that some of the OpenSHMEM people there, I think they share the interest with Open HPCA. So hopefully we will see something happening next year. So you have my email there. So if you want to join the group, drop me an email. I will help you join the group, have access to the resources. Some of the resources are not public right now, but we don't have any restrictions about who can join the group. So it's really open to everybody. So now I will switch very quickly to the next thing I prepared. Just to give you an idea of what the API looks like. Not the API, the UI, sorry. I just have to find it there. To log into my virtual machine. Here we go. Can you see my screen? I would assume
we can see it.
Okay.
Yes, we can see it.
That's the main page for the web UI, so you can connect remotely. So as you can see at the top, you have the 3 metrics, including overlap. Here, there is no support for smart NICs. So when you see the overlap is only 14%, that's why. It's really with a standard OpenMPI configuration, and that's it. So that's the main tab. You can find information about the latency, the bandwidth, and the overlap. You can access all the data and see the details of the results. It's quite useful, and that was requested by people. And another request I got a few months ago was to be able to compare things side by side. So this is also something that we can do. So that was a very quick overview of what we do and where we stand. Again, I would encourage everyone who is interested to join the group. Every ideas are good. I'm looking for feedback. I'm looking for new ideas to make this thing move forward. So yes, please join us if you have any interest. And I'm done with the presentation. So if you have any question, would it be on Open HPCA or UCC, we can do that now.
Thank you, Yerfa. Are there any questions? I have a question. do you plan to make this a community effort from the point of view of having regular calls like once a month or something to get started to bring other people to the project?
We have a call every 2 weeks. People are busy, so some of the calls are very short. Also, to be honest, right now, most of the technical work is done by me. So the content of the meetings every 2 weeks is really based on what I had the time to do. But yes, now that we have a release candidate, for example, our next meeting is not this Monday, but the following one. So I would be discussing a few PRs. I have to, I found a few bugs in the first release candidate, and I would like to change some of the default parameters I was talking about to make sure that it does not run for too long. So I have, I would prepare, it's not quite ready yet, a few pull requests to discuss these aspects and make sure we have agreement in the group. The GitHub repository is public, so you can see the issues, you can see the pull request.
Excellent. Yes, I really feel like there are several people from the community, especially national labs, that may be interested in this sort of effort, and it could, extending this to have a larger community and set of contributors will be very healthy for the project, and it will be very, very useful. And it's really exciting that you announced the effort at supercomputing and you're briefing us about this.
Steve is very involved, right? He tries to be there for every meeting. So we have Lano, we have Cynthia. Cynthia is giving very good feedback, and they're actually spending quite a bit of time to see how we can use smart networks in the different use cases that I presented at the beginning of the presentation. So they are really working on that, and they are not quite ready yet to make everything public, but I think there is consensus between them and the rest of the group that when it would be ready, it would be, some of it would be included in the suite. We also have Berkeley that is very involved from the national labs, and the same thing, they are working on a few of these use cases, and they also express interest into merging some of the work they did into the suite. So I really hope that for the next year, during the coming year, we will start to see more metrics put into the benchmark suite that address more use cases than just HPC.
Yes, excellent. And I also see a lot of synergies, especially with this project and some of the projects that I have seen in the community, like the spec HPC 2021 benchmark. I mean, that they potentially could go into a process of developing something in here, and then eventually could get standardized in a suite that can be, community more broader in the community. And there, this is like but first we need to gather what are the metrics that we need, and get a core set of contributors and users.
Yes, I mean, there is still a lot of work to do. I agree with you. So for example, I've been talking a lot about overlap, but overlap is also interesting if you don't have a smart network. So we know, for example, if you use, I don't know if it was publicly released, but I tried with a version of Sharp that was not public at the time, and you could achieve 100% overlap for some of the non-blocking collectives. So there is clearly a lot of interest from a pure benchmarking point of view, but OpenHPCA is really focusing on the smart NICs.
I see.
At least at first. And if we want to extend them, to extend the prototype we have to a broader context, I would say, maybe we need to create a different group or have a general discussion about how we want to do that.
Yes. That's an excellent point. Yes,
and there is still already a lot to do with the smart NICs, right? Especially in the hardware is still evolving. The ecosystem is still evolving quite a bit. So that's why I don't want to give the impression that this group is aiming at providing generic benchmarks for everything, because I think that would be too much.
Yes, absolutely, absolutely. So yes, so we started many years ago one called Spec Accel. That was an accelerator-based benchmark for offloading to the GPU. But some lessons learned from there could be useful here. Because and I'm very happy. It's very nice that you're focused on the smart NIC, because that's a very important execution model that you want to, an offloading model. So we definitely need to have these benchmarks as we currently don't have. So I think you are in the right track.
Thank you, and I agree with you. I mean, with OpenMP, you and I know very well that based on how you do the offloading and your compiler, you have very different results.
Yes, and, exactly.
With smart NICs, I think it will end up in the same situation. So that's really why I took the initiative to develop this new overlap benchmark, because even if now it's only one matrix overlap, it actually captures much more details under the cover. And hopefully that would be useful in the future when we get closer to the hardware and we start to try to understand better the differences between hardware, different software stack and whatnot.
Yes, excellent. Are there any other questions? I see some questions here in the chat. Benson says some of the variance can be due to interference from other jobs. How might one account for this?
So that's where the infrastructure is useful. Even if just you asking that question, I realized that I should do a modification to what we have. So I would take a note as soon as we are done talking. That's why we have an infrastructure to run the jobs. So for Slurm, you can put the option of singleton, and then it would be only for you. And again, this is why I think it's good to have an infrastructure that will control the execution of the benchmarks. So you know that you have some level of confidence on the end results. But yeah, clearly it has an impact. I mean, some of the data I got, and for the little demonstration I gave, I can tell you that, yes, I saw a difference for that run compared to the other one, because I think someone else was using the cluster at the same time and I was not using the entire platform. So there is ways to have a higher confidence into the results just using these features. Like if you have Slurm, make sure you use the good options. And again, I can support that. I have maybe a few default parameters to tweak here and there to make sure it happens. But we have everything required for that. And that's really, I think, the best we can do. But if you have any ideas on that, please let me know. I know I've been thinking about, and I was thinking more in terms of validation, right? So when I do a modification of the benchmarks, how do I make sure that it's still relevant on all the platforms I can run on? So I was thinking about it in the context of validation, meaning capture enough data at the time of the execution about what is happening to understand differences between results if I see any differences. But I don't have any code for that yet. I've been thinking about that for a different project as well. So I have PCs, but it's not in that prototype I talked about. And I don't think it will make it next year either, because it can be a quite complex thing to do. But yeah, that's clearly a problem. I keep it in mind in terms of configuration at the moment. It's all I have.